Welcome to Techie Wise. In today's video, we will have the discussion on advanced encryption standard, which is a block cipher symmetric key mechanism. It processes 128-bit block of plain text and produces a 128-bit block of ciphertext. What about the key size? It has three different options: 128-bit key, 192-bit or 256 bits key. So depending upon our requirement, we can choose the key size. So as we all know, if the size of the key increases, the security increases, but the amount of time taken for encryption and decryption will also increase. So based upon the requirement, we will choose the optimum key. And then it is an iterative approach. It is not based on the Feaster cipher structure. Yeah, iterative, the repetitive process. So what about this repetitive process? That is, it is not going to be a single step process. Instead, it involves multiple rounds. So here, the number of rounds is going to be dependent upon the key size. So if we are going for a 128-bit key version, then it involves 10 rounds. That is same step is going to be repeated 10 times. And then next comes 192-bit, then it involves 12 rounds, 256, then it involves 14 rounds, right? So here, this is an overview of the AES encryption. Here we are having the overview of 128-bit key version. So here you can see 10 rounds. Right? And then apart from the 10 rounds, we have one more additional functionality, which is the add round key functionality. So here, plain text is going to be given as input to the add round key function, where it is going to be XORed with the round key. So the plain text is going to be 128-bit plain text is going to be XORed with the round key. So XORed in the sense, I need the another operand should also be of size 128 bits. So this key is going to be given as input directly to the add round key function. So here key is of size 128-bit. So that is 4 words. So those 4 words are given as input to the add round key function. That is 4 32-bit words. Alright, now here you can see this add round key function is present in each and every 10 rounds. So single round requires 4 words as input. So how many additional words are required? 40 more words are required. But how many words are there in my key? Only 4 words. That is 128 divided by 32 is 4. So only 4 words are there. So word 0 to word 3 will be given as input to add round key function. For round 1 to round 10, this key needs to be expanded. So there is a key generation approach. So with the help of the key generation approach, key generation algorithm, the additional 40 words are generated. So this first 4 words generated is given as input to the first round. Next 4 words is generated is given as input to the next round. Like that, it goes on for all the 10 rounds. What are the functionalities in each and every round? So each round involves a 4-step process. So first comes substitution bytes. As the term suggests, instead of 1 byte, it is going to be converted to another byte. So next comes the shift row, shifting the positions. We can have a look into in detail further. Then next comes the mix column, and finally the add round key function. The same functionality is getting repeated for round number 1 to round number 9. What about round 10? Mix column is not there in round number 10. So the last round will not have the mix column functionality. Okay, so now we can have a look in depth with the each and every functionality in the round. So this is with regard to the byte substitution, that is bytes, the first part, substitution bytes, right? So here you can see this is my plain text, 128-bit plain text. Each and every 128 in the sense 32 bytes, right? 32 bytes. So this 32 bytes is placed as placed like this, right? So here you can see S00. So S00, first byte is taken. So first byte in the sense 8 bits will be there. So how I'm going to substitute? So this substitution is done with the help of an AES box, substitution box. So this substitution box will have 16 rows and 16 columns. In order to have a better clarity, we can see an example further. So this AES box will have 16 rows and 16 columns. So here you can see A, B, C, D, E, F, G, H. If this A, B, C, D, E, F, G, H is this particular byte, right? Then first 4 bits is used to represent the row, and then last 4 bytes is used to represent the column. And now I will be retrieving 1 byte from the AES box. So here AES box will have a 1 byte value. AES box will have a each entry will be of size 1 byte. It will be retrieved and then it is going to be substituted. Similarly, each and every byte will be substituted with the help of this AES box. So here we can have a look into. So this is the AES box. So let us consider. You can see there are 16 rows and 16 columns. Let us take this value. This value is C5. How I am going to substitute with the help of this AES box? C5. So first 4 bits is used to represent the row and the last 4 bits is used to represent the column. So C. So this row and C5, right? And this column. So what about the value to be substituted? A6. So C5 will be substituted as A6. So this is how all the all the 16 bytes will be substituted. All the 16 bytes will be substituted. Alright, so that's it with the byte substitution, and next comes the shift row. So in the case of shift row, that is output of the previous function, output of byte substitution will be given as input to the next functionality, which is shift row. In the case of shift row, the first 4 bits will be taken as such, right? So first 4 bits will be taken as such, and the next 4 bytes will be left circular shifted by 1 byte, right? So here we will go for 1 byte left circular shift. Each byte will be substituted by 1 byte left circular shift. So here you can see S10 will come here. So S11, S12, S13, S10. And the next row will be substituted by 2 byte left circular shift. So these 2 values will come here and these 2 will come here. So here you can see. And similarly, the last row will be left circular shifted by 3 bytes, right? So this is with regard to the shift row. So here we will handle the block of plain text as 16 bytes, and then we will proceed with the task. And next comes the mix column functionality. So that is output of the previous function, that is shift row will be given as input to the mix column. Here each column is processed separately. So here this is the output of the previous round, right? Output or not previous round, or previous function. Each column is processed separately and each byte is replaced by a value dependent on all 4 bytes of the column. If I want to replace this byte, then it is going to be dependent on all the values of that particular column. And how it is done? It is done with by means of matrix multiplication in Galois field 2 power 8 using the prime polynomial x power 8, x power 4 plus x cube plus 3x plus 1. Right? So this is the prime polynomial. So using this polynomial, this matrix is constructed. Right? So this matrix is constructed. So if I want to replace this value, then it is going to be dependent upon this row and this column. So for replacing this value, it is going to be dependent on all the values in that column. That's it. Again, in order to have a better clarity, we will see an example now on all these things. And next comes add round key functionality. So XOR state with 128-bit of round key, it is processed by column. So here this is the add round key function, and this is the output of the previous function. Just perform the XOR operation. So what we mean by XOR, if both the bytes remains the same, then the output is going to be 0. That is 1 1 0 0 0 0 1 0 1 0 1 1. Right? So that's the add round key function. And the next is going to be the key expansion process. So with regard to the key expansion process, as discussed earlier, we have 10 rounds, and each round should have a unique round key. So we have only 4 32-bit words. So this 4 32-bit words needs to be expanded to 40 32. That is totally 40 plus 4, 44 words are required. How this expansion takes place? This is how the expansion process takes place. So this is the key. So this is how the key bytes are placed. Byte 0, byte 1, byte 2, byte 3, byte 4, like that it is placed. First 4 bytes forms the first word. Next 4 bytes forms the next word. Like that it goes on. So from 128 bits, how many words I will have? I will have only 4 words, W0 to W3. And now, in order to generate the next subsequent words, so here, from each 4 word, I can generate the next 4 words. That is, if I have W0, W1, W2, W3, we can generate W4, W5, W6, W7. If I have these 4 words, with these words, I can generate the next set of 4 words. Right? So, how it is generated? So, this is how it is generated. So, W0. So, W0 is XORed with W3. So if I want, so here you can see I want to generate W4. So W4 is dependent on W0 and W3. So, and similarly, what about W5? W5 is dependent on W1 and W4. So what we mean by that? So if it is how we can generalize it? Wi is going to be dependent on Wi minus 1. So W5 is dependent on W4. So that is 5 minus 1, W4. And what about the next word? Wi minus 4. So here you can see W1, that is 5 minus 4, which is 1. So each word is dependent on the word 1 below it and 4 words below it, right? So here W4 is dependent on W0 and W3, W5 is dependent on W4 and W1, like that it goes on. And how it is generated? All the words are going to be generated with the help of a simple XOR operation. 3 out of 4 words, right? From 4 words, I'm going to generate next 4 words. 3 out of 4 words is going to be a simple XOR operation. And 1 out of 4 is going to involve a complex G function. It involves a G functionality. So which one word? So whose words index is a multiple of 4. Right, is a multiple of 4. That word is going to be dependent upon this G function. That is, W4 will be dependent on G function. If I want to generate W8, then it will be dependent on G function. W12 will be dependent on G function. Like that, it goes on. So the word which is the word's position, who is a multiple of 4, will be dependent upon the G function. So here you can see W5 is going to be a simple XOR between W4 and W2. And similarly, W6 is going to be an XOR between W5 and W3. W7 is an XOR between W6 and W4. But what about W4? It is going to be between G of W3 XORed with W0, right? So this is how the expansion process takes place. And what about this G function? So G function is a 3-step process. The circular byte left shift, that is left circular shift by 1 byte. Rotate word. So the first functionality is the rotate word, that is left circular shift by 1 byte. And next comes the byte substitution, which is taken care by the S box. And next comes the adding a round constant. So here this round constant will be unique for each and every round. So this round constant is going to be unique for each and every round. That's it with the AES algorithm. We can, in the next video, we can have a numerical example based upon this AES algorithm, that is key generation process, and then how the mixed column process works. All those things we can discuss in the next video. Thank you.